Welcome to the fifth lecture on computational mathematics with Sage Math. In this lecture, we will look at how to create our own functions in Python. We shall also look at how to make decisions based on certain conditions, or what is called branching in Python. So, let us get started. So, first let us look at creating user defined functions. So, recall that we have done computation of compound interest. So, let us just look at what we did. So, suppose there is a principal amount of 20,000 which is invested at the rate 5% for 5 years, then the amount after 5 years we calculated using this formula, principal into 1 plus r by 100 to the power number of years, and we can print this. Okay. Now, suppose we want to create a function for computing the amount returned when it is invested under compound interest. So, how do we do that? It is fairly simple. What we need to do is we need to simply write def and space, then write the name of the function. I am giving the name compound underscore interest, and then these are the arguments. So, in this case the arguments we want is the investment, that is the principal, the rate at which the interest rate is calculated, and the number of years for which the investment is made, and then calculate the amount using the same formula. So, I have just copied this particular line inside this, and then what it should return, the function should return some value. So, it is returning the amount after so many years of investment. So, let us run this. One of the important thing you should notice here, there is a colon here, and also these whatever comes after this colon, these two lines which is part of the body of the function are indented, right. So, indentation is very important in Python. So, for example, if, when you type colon and after that if you press enter, automatically your cursor will go inside and all these things will become aligned to this. So, even if I go back and then hit enter, again this return amount will be aligned with amount. Okay. So, let us run this. Once we have run this, now how do we call this function? So, I have to simply say compound interest and input the principal, input the rate and the number of years. So, let us call this function. So, I will call this as amount equal to compound underscore interest, that is the name of the function, and let us say we have invested, instead of 20,000, suppose we have invested 50,000 rupees, and at the rate let us say 3.5%, and it is invested for 7 years, and then that is the amount you will get, and you want to print what will be the amount received after 7 years. So, this is 63,613.9631, and of course, we are printing only 4 decimal places. You can print more decimal places, or you can print significant number of digits. All these possibilities are there. Now, suppose you want this compound interest to be calculated not annually, but if suppose it is calculated quarterly or it is calculated every month, etc. So, in that case the number of times compound interest calculated per year, we can let us say give this as another argument n equal to n, and here when we say n is equal to 1, this is a default parameter. So, even if you do not give this, it will take default value as n, but in case you give this value, it will calculate. So, that is the only change in the previous user defined function. Let me call this compound interest 1. compound interest 1, and let us run this, and now again let us call this function. So, when we call this function, I have to say compound interest 1, and let us say the investment is made 50,000, and again this is 3.5, and for 5 years this is the a number of times it is calculated is 3. That means, every quarter the interest is calculated, and then let us print what are the amount we get. So, again you can see here this amount is 59,502. Earlier it was 7 years. Now, so let us make it 7 years and then see what is the amount. So, you can see that amount in this case is more than the previous amount when the interest was calculated annually. Okay. So, suppose I have not given this n equal to 3. If I do not give this n equal to 3, then what will happen? Still it will calculate, but it will take the default value of n as 1. So, that is how you could also you need not say n equal to, I can simply say n, this is argument, this is 3, then again it will calculate this. So, you need not always say n equal to, okay, right. So, this is how you define a user defined function. Sometimes you give some default value to the argument. Okay. Now, let us look at another example. This again we have done earlier, finding roots of a quadratic ax square plus bx plus c equal to 0. We want to make a user defined function for this. So, first let us make a user defined function when we know that the roots exist, and the roots we know that it is given by minus b plus minus b square root b square minus 4 ac whole thing upon 2a, right. In case the roots are real, this is what we have done. So, this is what we already have done. So, I have just copied this from the earlier the class. So, we are first importing this square root from math module, and suppose a b c is equal to 2 3 minus 2 respectively. So, a is 2, b is 3 and c is minus 2. So, we are looking at 2x square plus 3x minus 2 is equal to 0, and the roots are x 1 is equal to minus b plus square root b square minus 4 ac upon 2a, and x 2 is minus b minus square root b square minus 4 ac upon 2a, and then we can print what are the roots. So, let us execute this. Now, we want to make user defined function out of this. So, the what will be the inputs in this case, or the arguments? It will be a, b and c. So, you input a, b and c and return the values x 1, x 2. Okay. Now, so let us do that. So, we are calling this function as QUAD quad, and the arguments are a, b, c, and they calculate x 1 is equal to this, x 2 equal to this, and then return x 1, x 2. So, in this case the two returns are there, x 1 and x 2. Okay. So, let us run this, and let us call this function quad. So, when we call this function, since the returns are two things, x 1 and x 2, both the roots, I will store the sum x 1 and x 2. So, first root will be stored in x 1, second root will be stored in x 2. You may be wondering, here I have given x 1 and here I have given x 2. So, this is same thing, x 1 x 2 I have to store. Not, that is not necessary. I can even say r 1 comma r 2. Okay. And in this case we will change this to r 1, and this is r 2. Now, let us run this. You will get the roots of the quadratic are 0.5 and minus 2.0. Let us change the value. Suppose we want, instead of 2 here, I will make it 1, and then the roots are this. Of course, it is printing so many decimal places. You can put here, for example, colon dot 4f, and here also colon dot 4f, then it will print only colon, then it will print only 4 decimal places. So, what happens in case the roots are imaginary? So, here the x1 x2 are calculated when the roots are real, that means discriminant is non-negative. Now, suppose I have let us say instead of this I make it here 5, and then when I run this it will say domain error. Okay. Right. So, you can see here math domain error, because in this case the discriminant is negative and which is not calculated. So, that is not taken care in this case. Later on we will look at all possible cases and we will make a user defined function out of this. Okay. Now, similarly, suppose we want to make a user defined function for calculating the area of a triangle using Heron's formula, then we can again, since Heron's formula will require calculation of a square root, let us import a square root from math module, and then the name of the function is Heron, the arguments are a, b, c, and calculate s is equal to semi perimeter and the area is a, and then return the area. So, this is fairly simple, and let us again call this. So, a, b, c are 3, 7, 9 and the area of this triangle is 8.7856. Okay. Suppose what if I give for example 3, 7 and let us say 12, then because this does not form a triangle, right. We know that 3 sides will form triangle and the property should be sum of any 2 sides should be bigger than third side, which is not the case in this. So, again it is giving you math domain error, that is because this does not form a triangle and one of these things in s minus a, s minus b, for in this case for example s minus c will become negative, and that is why you are getting domain error. So, let us put this back to here 8. Okay, right. Now, suppose for example, in calculating the square root, the roots depends upon whether the discriminant is non-negative or negative. So, suppose we want to check such cases, then how do we do that? Even in case of a triangle, we want to check whether 3 sides forms a triangle or not. When we want to, in case it is a triangle, what kind of triangle it is, all these things if I want to consider, then we can use what is called if condition, if and else condition, which is. So, how do we make if and else condition? So, general syntax for if and else is something like this: if and in the bracket or even without bracket you write condition. It could be one condition or it could be several conditions. So, and then these conditions should be logical conditions. So, if you are using equality, it should be logical equal to and things like that, and then put colon here, again that is important, and then whatever the expression you want to evaluate or statement you would put it, and else again this else is aligned with the if, and then again put colon, and then so in case these conditions are satisfied, it will evaluate this statement, otherwise it will evaluate this statement. Okay, right. So, let us make use of this. And suppose we want to print distinction in case the marks is greater than equal to 75 and print no distinction otherwise. So, how do I write Python codes for this? So, marks is let us say 70, and in case if in the bracket marks greater than equal to 75, then print distinction, and otherwise that is else again colon print no distinction. So, if I run this, since the marks is 70 which is less than 75, so it will go to this particular branch and it will print no distinction. If I have marks let us say 78, and then if I run this, it will print distinction. So, this branch is taken into consideration. Of course, this if condition has existence without else also. So, suppose if I cut this, and just run this one, so it will still work. If I let us say instead of 78, if I have 70, then it will not print anything, because there is only one condition it is checking is mark 7 greater than equal to 75. Okay. So, yeah. So, and this has to be aligned, the alignment has to be proper, the indentation is very important, and of course, if you do not put colon here, then it will give you an error. It gives you an error which says that the syntax is invalid. Okay. And if you do not align this print like this, suppose I put everything in single line, again it will give you an error. It says that expected indented block. Okay. So, that is also important. So, keep all these things in mind, and again advantage of using this kind of editor is that when I press enter, automatically cursor goes inside, and similarly in case of this it goes inside. Okay. So, even if you put, let us say this, if you put not aligned properly, it will give you an error, again expected indentation. So, and colon is also important. The colon simply tells you that okay, something is to follow, it is not complete, this some statement has to follow, that is what it means roughly. Okay. Now, suppose I have another condition, for example, if marks is greater than equal to 75, you print distinction. In case it is greater than equal to 60, print let us say first division, and otherwise you simply say completed, the course is completed. So, how do I say that? So, in this else we have to have another if condition. So, we can use what is called nested if. Okay. So, let us look at that. So, this is how you write first up to here, this is all right, and after that we are saying if marks is greater than equal to 75, then print first division else, right. So, this whole thing is inside else. Okay. Otherwise, you print completed. Now, when you run this, it prints no distinction. Sorry, let me go down. This is the one. Okay. So, it is say first division, if it is 60, suppose the marks is let us say 40, and then it should print just completed. So, whatever is the marks below 60, it will say completed. You can have more condition inside this. Of course, you can also combine this if and else together, and you can use elif. So, let me show you. You can combine else and if together, and it should be combining if and else and if together to elif. So, let me do that. So, in this case you see that this particular, just one second, this else and if is combined together in elif, and then marks is greater than equal to 60, then first division else print completed. So, this is somewhat you are just saving few lines. Okay. Right. So, you can have actually many nestings, you can have so many conditions inside. Okay. Now, for example, suppose we input 3 real numbers, positive real numbers a, b, c, and want to check whether it forms a triangle. So, we know that the condition, we know conditions on a, b, c under which they are sides of a triangle, namely sum of any two sides should be bigger than the third side. So, how do we do that? So, in this case we need to have more than one condition. So, a, b, c are in this case 4, 6, 6, let me say 4, 6, 7, and if a plus b is greater than c, and so this is the combination, this we are joining the two conditions by and, or you can write or depending upon what you need to use. So, a plus b is greater than c, or a plus c should be bigger than b, and a plus c should be bigger than a. In this case, we want to print a, b, c are sides of a triangle, otherwise they are not sides of a triangle. So, here inside the if we have used 3 conditions and they are joined by AND. Okay. Similarly, suppose you want to make a user defined function out of it. That means you want to check whether ABC forms a triangle or not. So, we can simply copy paste inside this the function name. So, the function name I am giving is underscore triangle and the arguments are ABC and then colon. If this condition is satisfied, then print return true. That means it will be true, otherwise return false. So, instead of instead of printing something, we are saying return true or false. So, let us run this and let us call this. So, if I say triangle 10 10 and let us say 15. So, this is the answer is true, it forms a triangle. Instead of 15, if I say 25, then A plus B is not greater than C. So, it should say false, right. Suppose instead of just printing whether it forms a triangle or not, in case it forms a triangle, we want to check whether it is an equilateral triangle or isosceles triangle or a scalene triangle. In that case, we can say check if A plus B is greater than C and this. So, this is the first condition to check if it is a triangle. So, what we are doing in the previous condition, if this is true, instead of true, then we are looking at another if else, and we are checking in case A equal to B and B equal to C, then it will be an equilateral triangle. If else if A is equal to B or B is equal to C or A is equal to C, then it will be an isosceles triangle, and otherwise it will be scalene triangle, right. And if this condition is not satisfied, then it will not be a triangle. So, that is why this else is aligned with the first if, and these if else are inside the first block, first if condition. Okay. So, let us execute this. So, in this case, this is a scalene triangle. If I say here 5 and then run this, this is an isosceles triangle. Now, suppose I have put this as also as 5, this is this as 5, then this is an equilateral triangle. And again you can make a user defined function out of this. So, let me call this as a triangle. So, all I am doing is that whatever we have done here, it is just copied inside this function called triangle, and then ABC colon, and then these things are just actually copied inside this. Okay. So, if I run this, I have made a triangle function which checks whether ABC forms a triangle. If it forms a triangle, it checks whether it is an equilateral triangle or isosceles triangle or a scalene triangle, and if it does not form a triangle, it simply returns not a triangle. Okay. So, if I execute this, it says it is an isosceles triangle. If I say, for example, if I say 10 in this case, then it says it is not a triangle. Okay. So, you can see here making user defined function is very easy, but actually what you need to do is first of all try to write the body separately, and if that runs, then all you need to do is just copy paste this body from the previous one. Okay. So, and also try to split, when you have to create a user defined function, try to split the problem into smaller problem and then try to run. Okay. Now, suppose we want to again write a user defined function for finding roots of a quadratic, and we want to cover all the possible cases. That means, look at when the discriminant is non-negative, then print the roots, and if it is negative, then print the roots. Okay. So, how do we do that? So, this is again we have used this if and else. So, two things I am importing. One is square root from math module, and in case the roots this discriminant is negative, then the roots will be complex, and in that case we can compute the complex roots. So, this square root function from C math, it is imported as C sqrt. Okay. So, let us again define user defined function. Solve underscore quadratic is the name and a, b, c are the arguments. So, first we will check if a is 0, then we will check whether b is 0. If b is non-zero, the root will have only one root, that is minus a upon b, and if b is also 0, then you get 0, that means you have just a constant equal to something which is not a quadratic, you cannot do anything. So, in that case we are printing that it has no root, and so if this is not the case, if a is equal to 0 is not true, that means a is non-zero, in that case we will check the discriminant. This is the discriminant, and then once you have found the discriminant, you check whether discriminant is non-negative. If discriminant is non-negative, then print the roots are real, and then compute the roots x 1 x 2, and then print the two roots. So, here we are not using return, we are using print. You can also use return, and otherwise. So, if discriminant is this else is for this if, so otherwise the roots are imaginary, that means if this is not true, means discriminant is less than 0. So, the roots are imaginary, and then print the two roots x 1 x 2 using c square root, that means it is taking square root from complex math. Okay. So, that is the function. It is fairly simple. Let us again run this, call this function, and in this case suppose I say solve x square plus 3x plus 5 equal to 0, the roots are imaginary and it is printing the imaginary roots. If I put here 0, it will have only one root, that is what it is printing. If this is also 0, it will give me the error that it has no root. So, that is how you can make use of this function. You could have also try to use return instead of print. So, you may just try to change this, wherever you have print, you can change it to return. Of course, in this case here there is no return, you have to have print, but here x 1 x 2 you can return. So, I expect you to do that exercise. Now, before I end, let me leave you with some simple exercises which will make use of creating user defined function based on certain conditions. Okay. So, these are the few exercises. The first exercise is input 3 real numbers and print the maximum of their absolute values. Okay. The absolute value is you can get that from math module, and similarly the next exercise is input an investment and calculate the return. The bank gives return at 3.4%, but that depends upon whether the person is senior citizen or not a senior citizen. In case of senior citizen, the return is through compound interest, otherwise simple interest. And then third one is create a user defined function to input a list of marks. So, you know how to create a list. So, your argument will be a list, and then it should calculate what is the number of elements in the list, and based on that it should calculate the average, and based on the average you can assign the grades A, B, C, D. You can have your own criteria of grading. And the fourth one is create a user defined function for this Gaussian function. This is f x equal to 1 upon square root 2 pi and times s and e to the power minus half x minus m by s to the whole square, and m and s you can take some default value. For example, m can take m equal to 0 and s equal to 1. So, that is actually standard normal distribution function. Okay. And the fifth problem is input a point. You can input as a order pair, or you can input as a for example as a tuple, and check if that point is origin. If it is lying on the x axis or y axis, you can print that, and otherwise you can print in which quadrant it lies, and also print the distance between that point and 1 comma minus 1. So, these are the few exercises. Okay. So, thank you very much. I will see you in the next lecture, and in these exercises you should solve. Of course, we will also upload the solution of these problems. They are fairly simple. Thank you very much.